Hello, in this tutorial I will show you how to implement matrices and implement a method for multiplying them. So without further ado, let's begin. So I need a matrix class. Matrix. Okay, let's take this off. And, final means that the matrix, this class cannot be derived. You cannot have a derivation of this class. Let's start. Actually, okay. In general, when you write your code to publish somewhere else, it makes sense to actually check that, for instance, this rows and columns attributes are reasonable, so that they are not zero or negative. Check rows and rows. Void check columns. Okay. And so rows. So the idea is that I reuse the code and not write the same thing over and over again. Yeah, of course we need final double something where to actually store our matrix values. So we have this array int. So I will use double rows times columns. Okay, so you would expect a two-dimensional array here, but in some scenarios it might be better to use just a simple one-dimensional array, because maybe your CPU has enough large the cache, so things will compute a little bit faster that way. And of course I need some function to convert between two-dimensional indices and one-dimensional indices. So I get this int x, int y, y times. Okay, I need also final rows, final int columns. Actually, we can do a little better here. So we have this kind of stuff. Of course, I need int. Int once again. Yes. So basically, I can do like this. Rows. Okay, now let's make it pretty, right? Columns plus x. Yeah. And the next we need a getter and setter for particular matrix entry. So oops, public double get int x int y. I would normally validate that x and y point to does not point outside of the matrix, but I think I will leave it for this tutorial right here. So I get like return array index x y public void set int x int y double value. Well, it's just simple as that. Alright. I think I will check this after all. So check x and check y. Okay, I think I'm too lazy to make my code less dry, so we'll just check x and oops. Actually, there is index out of bounds exception x equal, okay, now x is negative plus x. If x is equal or larger than columns, index bar, x is too large, value of x plus next row as cons. Actually, this is kind of two variables, but actually I like to let the client programmer know what exactly went wrong, so I'm very explicit about error messages as well. So I don't say that this is the right way, but I think it's just my way. So let's do the same for the y coordinate. Check y. Actually, I can do Control R like this. Matrix has rows, and rows. Oops, and then rows. Okay, right. Right. So I will need a. I will need some this so-called copy constructor because I wanted some convenient way of copying matrices. So I just write public matrix matrix other objects require known other matrix is known. Okay. So I'll do just this rows other rows this comes and this array other array so let's actually I just realized that I need also to I need some methods for returning the number of rows and columns. Rows. It's misleading actually. I think I will just name rows. Public and columns. Oh, okay, I think it's a bad name. Get row num. Okay, I will leave it like this. Get rows. Get columns. Okay. So let's have an interface here. Matrix, multiplier. Okay. Default comments off. Right. So public matrix multiply matrix left matrix right. Okay. And so you might ask me why I actually define an interface. Namely, I really intend to actually implement a single-threaded sequential implementation of this multiplication algorithm, and in the next video I plan to actually show you how to make it run in several threads in order to run faster. So okay, well, by the way, if you look at this package right here, com.youtube.tutorial.matrix, this is kind of the right way for naming Java packages. Namely, you take your domain name like org.something awesome.tutorial.matrix.integral etc. So but actually, if I have this matrix multiplier interface, it's in some projects people use sub package called support, which actually contains the actual implementations of that matrix multiplier interface. So I will just name it plus sequential matrix multiplier. Okay. All right. So it implements matrix multiplier. Okay. Right. First of all, let's check that there are not null. That matrix is null. And another, the right one. No. Okay. Now we know if these two statements pass, we know that both left and right are existing matrices. Actually, I need to check them. Check dimensions. Right. This is important actually. Wait for check dimensions. Matrix. Right. So the idea was that if left, sorry, let me think about it. Get columns, not class, come on. Get columns not equal to right. Get rows. Row new argument exception trying to multiply non actually new line here, trying to multiply non compatible multiply non-compatible matrices. Plus columns of head matrix. Let get column rows of matrix up. Get rows. Okay. All right. So the actual multiplication for let me see, left x 0. No. Left row 0. Left row left rows plus left row and for right column right column right get columns. I think I will rename it better. So we have twice y. So this is the y coordinate of the result matrix, and I will do the same for the axis. X plus x. Okay. For each we start from 0 sum. Actually, we need the matrix here. Matrix result. New matrix. Left. Get rows. Right. Get columns. Okay. And I'm gonna iterate here 0 e less than left get columns plus e results set x y sum, and we need to left get right get. Okay. Y. Right. Okay, I will test it shortly. And actually, it makes sense to define the string method as well, so that I can neatly print. I'm sorry. I need to put it here. Public string to string. Take the annotation and string little sb string sb to string what's input L, yes. All right. There is sb append separator. Separator is sent for x0 x columns plus x. Oh boy. Must be append get x, y, and some space. Wait a minute. Does this make any sense? I think it does, more or less. Okay. So, and finally we need some entry points. So I will put like class demo demonstration. Okay. Right. Matrix and one is new matrix 2 and 2. Matrix and 2 new matrix 2 and 2. Actually, I will do rather m1 set 0 0 m1 set 0 oops, m1 so set 0 1 0 finally okay. So I believe we can just print it to see that contains this like this is X not Y, so yeah, okay. So next we're gonna test this copy constructor. So new matrix copy from M1. So space select into okay. Yeah. Next, I take a matrix multiplier new sequence shell matrix multiplier, alright, and result multiply and 1 and 2. Finally, sort. Bring the result. Actually, I need space here. Right. Oh yeah. Okay. So no. Next. So this element here 7. Namely, it must be just a moment. 1 times 1 plus 2 times 3 matches, then 1 times wait a minute, 2 plus 2 times 4 2 plus 8 10 and then let me think, 1 no 3 times 1 plus 4 times 3, so this is 15, and finally 3 times 3 plus 4 times 4, this is 16 plus wait a minute, oh no, it's not 3, it's 2. yeah, 22. So this is correct. And well, I think I will end this part one of this metric stuff video, and I will check that my algorithm is actually correct, and if it is not, I will not pause this video. So if you see it, you may be sure that it's correct. So basically, what I want you to note is that multiplication is done in such a fashion that you can easily parallelize it, because there's no dependence between one value of result matrix to another. So the idea is that when I start this loop right here, I just iterate through all rows of the left matrix. So in parallel implementation, the one idea is that I actually split the set of rows of the left matrix into, say, 2 or 4 groups, and I do this multiplication for each group in its own computational thread. So okay, this is enough for today, and I will post the parallel implementation very soon. If you have any questions, or maybe you want to tell how to improve my videos, just leave a message, and yeah, well, thank you for watching, and see you later.